Hi everyone, welcome to the November 2016 edition of the Deis community meeting. Today we're going to share some updates about workflow and Helm and also introduce a new project we've been cooking up called Steward. But before we jump into that, I'd like to just kind of pause for a minute and give a little context on these three projects and explain why they're really important to the Kubernetes community just generally. So Workflow is the project that most folks who are familiar with Deis know and love, and really its importance stems from it is probably the easiest way to manage 12-factor applications on Kubernetes. And some of the reasons for that are, mainly it extends this popular model for application development, this sort of Heroku-style model. It also doesn't require deep knowledge of Docker or Kubernetes to get started. And as a result of that, it ends up being one of the fastest ways folks can deliver value with Kubernetes, stand up Kubernetes, install workflow on it, boom, your developers are off to the races. So that's pretty important. And something that that we're continuing to invest in for those reasons. The next project is Helm, and you've probably been familiar with Helm, or at least Helm Classic, as the installer for the Deis workflow project. But more generally, Helm is really the easiest way to manage Kubernetes native applications. Those of you who have worked with Kubernetes have probably realized there is no primitive for how you manage sets of Kubernetes manifests that require templating and config injection and sort of management of the application lifecycle for that set of manifests over time. It's a really, really important missing piece of Kubernetes, frankly, and this allows folks who want to do Kubernetes native things to do so in a way that goes beyond 12-factor apps, which is really the sort of the focus of workflow. I think just broadly, Kubernetes also just needs a package manager. It needs to be really easy to install Kubernetes and start Helm install X or Y and get up and running really quickly. So that's an important reason we're continuing to invest in Helm. And the last project, Steward, which we're going to talk about later, the overview here is it needs to be really simple for folks to connect Kubernetes applications with resources that may live either on the cluster or off the cluster, things like an RDS database or an S3 bucket or a legacy Oracle or something like that. And that's really important because no application is an island. Every application has a set of services that it depends on. And if you think about what most folks do today is they do the equivalent of node passing, right? Where they take configuration coordinates like, what the path to the service is, the host name and the username and password, which are often provisioned manually, and they inject that as configuration into the consuming application. And that's not really scalable. And as you sort of add to the amount of services that you have to manage in that way, it creates a massive management headache. So what Steward's really trying to do is facilitate automatic provisioning and binding to backing services. And once we can do this in a Kubernetes native way, that then facilitates things like Deis add-ons for the Deis workflow product, where you can actually have an add-on system that will allow you to spin up a Postgres on demand. So all these projects really fall under the category of open source software that makes it easy for teams to create and manage applications on Kubernetes. We just want to make this stuff dead simple for folks, right? But interestingly, these are also solving problems that we are seeing in the wild with customers as we kind of work with folks in a professional services capacity. So we're pretty confident that these are projects that are very valuable to the Kubernetes community at large. So hopefully that context is helpful. With that out of the way, I'm going to go ahead and kick it over to Matt Fisher to give us an update on the workflow project. Matt.
Hey guys. So I just wanted to give you guys a little bit of an update on the workflow side, also the original Deis V1, now V2. Just giving off some of the features that were landed in version 2.8.0. We landed experimental support for workflow with the new Kubernetes Helm. So what we're using right now to install workflow is the Helm Classic side of things. But there's also Helm itself, which is starting to approach stability for version 1.0. There's beta releases right now. We've been testing since the alpha, and we have experimental support for it in the way that we have the charts available, and we tested it at the last release, and we're looking to do a migration strategy over from the old Helm Classic to the new Helm, so people can transition over from Helm Classic to the new Helm at some point. So see that in the next coming weeks. But for now, if you want to completely stand up a brand new workflow cluster, you could experiment and try out the new Helm. We've also allowed InfluxDB for the monitoring system to be installed offsite the cluster. So if you want to have your own InfluxDB system installed somewhere else, you can communicate with it other ways. Same as with database on RDS and all of our other components that are good for stateful services that can be installed outside. We've also allowed admin user registration when the mode is admin only. So when your registration mode is admin only and you register a user, but you don't have any users registered, it says that you need to register an admin user or an administrator needs to register your account, but there's no account to install. So we fixed that where if there's no users present in the system at the time and you do a Deis register when the registration mode is admin only, it'll create the administrator user and then it immediately shuts off all access. So if you're an administrator user, that's the only account that can create accounts. We fixed a bug when trying to roll back with no build, pretty self-explanatory. We added tests for both ECDSA and ED25519 SSH keys. So you can use that and install those as keys add and then use them in the builder. We added, this is actually kind of nice. We added in Docker Builder, which is the one that does when you do git push Deis master with a Docker file in your application. We've added the -- pull flag to the Docker build. And this is kind of important in the sense that when you do a Docker build for an application and you're using a from tag from an image that is a rolling image or a mutable tag, like say Ubuntu Trusty or Debian Jessie or something on those same lines that get security updates over time. Before, when you do a Docker build, it would pull it the very first time because it's not present on the system, and it would continue using that exact same image over the next future builds. However, that poses a problem because when a security release is updated for the downstream image itself, like Ubuntu Trusty, when you do a next git push Deis master, it's got the previous version that was cached, so it's just going to use that one. But with the pull flag, now we actually pull the image down at every time we do a Docker build. So that'll allow, it's a little bit of a performance hit for users that use tags that are completely immutable, but it is pretty much negligible because it's just a quick check on the index. So that's quite nice for people who are using immutable tags or base systems like that. And then the last thing is that FluentD now, which is the log collection system for the logger, now allows itself to stop dropping itself from being collected. So FluentD won't collect itself. A little bit meta there. So that's on the update side for version 2.8 if you want to upgrade to there. Then last week, Matt Boersma did a bit of a demo on the last SIG apps meeting in Kubernetes. And we were talking about not only just giving a demonstration about workflow, but one of the topics we wanted to talk about was making components inside workflow a lot more useful on their own. Not just to workflow itself, it's a bunch of components that are all useful, but they're all useful to workflow itself. We want to make them a lot more useful to the Kubernetes community as a whole. So if you have any, we wanted to start this conversation on both upstreaming and contributing projects that are more useful as a whole and potentially replacing bits and pieces with what we've got. So currently there's one component that we've contributed upstream at this time, which is the registry proxy, which is the one that proxies requests from the local Docker host over to the registry installed inside workflow. But it's also useful for anyone that wants to proxy requests over to any registry. So we've contributed that upstream. You can see that at the pull request for Kubernetes 35797. And then we're also looking at other ways, like currently we're looking at the Kubernetes Incubator Client Python library for the controller, looking to both integrate it into the controller so we're no longer using our own baked-in HTTP lib stuff and using something, and also contributing back to that project if there's any holes that's missing or anything that we see that we could use there. So that's one thing we'd like to do. If you have any other ideas or any other contribution projects that would be nice to kind of move upstream, please let us know, either by like dropping in the community channel and dropping an idea, or drop an issue. Anything will do and helpful. We're just kind of looking for ideas of what would be useful and what the community would like. Onto the release cycles. About after releasing version 2.8.0, workflow itself has kind of become more of a mature and stable product as we're getting into version 2.8.0. And we're starting to see a bit of a slowdown on feature development over every 2 weeks, because it's a lot of velocity, and now that the project itself is becoming a lot less volatile, less features are coming out in 2 weeks. So we were liking to propose the idea of doing a monthly release cycle on the first Thursday of each month instead of every 2 weeks. We're proposing this because we just want to release new versions with the same amount of features as previous releases. And if you're interested in voicing your opinion on the matter, whether for or against, just drop a comment at Deis Workflow 586, and I'll drop these links in the chat in a minute. And then the last thing I wanted to talk about was we're interested in growing the number of active contributors in the same way that we're wanting to contribute things upstream. We'd also like to see a little bit more active contributors in the project, and we're actively looking at that. So if we're just looking for feedback for ideas on how to get more active contributors, if people have ideas or know of any experience on kind of stimulating that idea of getting people more interested in kind of taking on the code. So if you're interested in that, either leave us another link, either in Slack or in chat here, and we'll have a conversation. With that, I'll pass off the mic to Adam to talk about a Helm update.
Yeah, thanks. My name is Adam. I'm a core maintainer on the Helm project. So I got a short but exciting update. We just cut a version 2 RC1 this week, which is very exciting. This has been a long process for V2. It's a complete rewrite from Helm Classic, which Matt was talking about and Gabe was talking about earlier. It's a complete rewrite and then some, maybe a few extra rewrites in there. So it was quite a journey. Quite a few changes took place through this last cycle. Big shout out to the community. I think that was huge in getting this, everything, all the issues that we had ironed out. We got the right people involved, and the community really helped us out with focus and direction. And I think we built something really cool this time. So if you've been thinking about checking it out, now's the time to go on and check out the repo. It's under the Kubernetes org on GitHub. I think we're up to 65 contributors now, so that's awesome. Also, the charts repository is just taken off, especially this past week. We just had a meeting with some of the maintainers on the chart repos, and they referred to it as Chartmageddon. So I think there's like 20 open PRs on that, and the stable repository has been growing quite a bit, and it's just been awesome recently. So go on, check it out. We're in Kubernetes Slack. If you have any questions or want to get involved. We're also going to be meeting at KubeCon next week. Kind of talk about roadmap, talk about what's next post V2. We're going to be meeting at the Sheraton Hotel. Michelle just posted an Eventbrite thing on there with all the details. So it's the Monday before KubeCon starts. Meeting at the hotel, we're going to be talking about roadmap, best practices for charts and Kubernetes. It's going to be, if anybody's involved with SIG apps, it's kind of the same format as that we're going to be going through. So if you have any questions about that or want to attend, you can ping me in Slack or Michelle, who is organizing it. And that's all for Helm.
Awesome. Thanks, Adam. Aaron, you there? You ready to take it away with Steward?
Yeah. I'm going to share my screen here. Cool. All right. So Gabe touched on Steward a bit right at the beginning here. I just wanted to give a little bit more color, give a little bit more detail on what we're doing in this space. So first of all, we pursued a lot of those goals that Gabe mentioned, and we built a prototype of this thing. You can go to github.com/deis/steward, same spelling as you see on this slide. You can check out what we've got so far. We've demoed it to quite a few people, and if you have questions on it, please feel free to go into the community channel or drop an issue on the repo. Second of all, before I get started with this slide deck, I want to mention also we're pretty heavily involved with the special interest group in the Kubernetes community. It's SIG-Service-catalog. We're working with them to kind of advance this concept of a service broker inside of Kubernetes. And we're going to be evolving the Steward project as well in accordance with kind of what we work with them on. So let's back up. Let's talk about why Steward in the first place and expand a bunch on what Gabe mentioned. So we've kind of got two sides of the house in a mature application on Kubernetes. We've got the left side, which is an application developer. And this is really the person that's going to build out the application and do some of the high-level administration of their application in production. So we've internally called this kind of the 13th factor. So we've got a 12-factor app, but there's always something external to your app, almost always, that you need. So these are things like databases and caches, maybe SendGrid or some other kind of software as a service offering. And as an application developer, the kind of current state of the art is you just have to go to your operations team. Maybe they'll write something down, a Post-it note for you with credentials, and then you inject it into your app. So there's this problem of discoverability. There's this problem of kind of getting access to those things. And then there's this problem of configuring your application to use those things. Now let's go to the other side of the house. And we've kind of got the opposite problem as a cluster operator. You're on the other side. You have to somehow communicate that these apps exist or these SaaS products exist to your application developers. And then you have to get them the credentials for those things. And so on both sides, there's kind of this communication that has to happen. And as you grow your app and as you grow your list of service offerings, SaaS products again, or on-clustered databases and so on and so forth, it gets that much harder to manage all these services between the developer and the cluster operator. So this is our logo for Steward. There's kind of internal debate on whether this is a robot or a serving platter with eyes. So if you've got opinions, drop them into the community channel. We'd love to hear. Maybe it's none of those. Maybe you've got something else. But we really like this logo. It's really cool. I certainly love it. So specific to Steward, how are we going to solve that communication barrier between the app developer and the cluster operator? So first and foremost, of course, we're making it easy to expose those services from the cluster operator side, and then make it even easier for that app developer side to consume them. And we're doing that by decoupling the two concerns. So the service operator, the cluster operator side, is able to communicate through the Steward abstraction what services are available. And then the app developer side is able to request access to those services in a very structured and auditable way. So we're using these standard Kubernetes resources, which we can get into. There's a lot of detail on that in the GitHub repo. We're using these as the standard interface for how to do things like provision a new service, bind to that service, which is get the credentials for that service, configure your app to use the binding credentials, and then unwind that stuff and unbind your app from the service and deprovision that service. So this is kind of what the very highest level of architecture looks like. So that blue box on the bottom left, that's the application operator, the application developer. They look at something we're calling a service catalog. When they find an entry in the service catalog that they want to use, So again, something like SendGrid or a database. They submit a Kubernetes resource. The broker, which is in our case Steward, it sees that resource has been created, and then it goes on the back end and talks to the service provider to do the right operation. So again, this is either a provision or a bind, unbind, a deprovision. And eventually, let's take the bind case, you get back some credentials, and then the broker, again, that's Steward, it exposes those credentials in a structured way back to the application developer, such that the application developer can get those credentials into their app and then start using the service. So let's go through very briefly the whole kind of list of people who are concerned here. I'm not going to give too much detail on any one of these. You can kind of see we've got at the top the application concerned people, and then in the middle there are the people on the other side of that communication barrier who are interested in the cluster. And then those bottom three are the mechanisms we're using to facilitate the communication between the app side and the cluster operator side. So we're going to go kind of one level a little bit deeper, and we're going to talk about how specifically we're implementing the backend, so the thing that the broker is talking to. So we've chosen to use the standard Cloud Foundry Service Broker API, and I'll post a link for some documentation on what that API is and does. And so Steward ends up talking to the standard CF Service Broker API to fulfill these operations. So if an application developer, for example, tells Steward that it wants to do a bind, that gets translated by Steward into a standard bind REST API call on the back end. And then the CF Service Broker returns a standard response body, and then Steward again translates that back into a Kubernetes resource that the application can really easily consume and then successfully start using the service. So specific to Steward, it does two major things. I alluded to the second one quite a few times. So the second one is watching for those resources and doing stuff with the Cloud Foundry Service Broker. But the top one I didn't talk too much about. So when Steward starts up, it talks to one of those backing Cloud Foundry Service Brokers, and it gets back a catalog of services that the broker is able to offer. Once it gets back that catalog, it converts that, translates it into another Kubernetes resource, which we're using something called a third-party resource, which I'll post some details about. Once it does that translation, it writes a list of third-party resources into Kubernetes itself, and then an application developer can really easily access that list and decide from the catalog which services it wants or needs to use. And then, of course, it goes into that standard workflow I mentioned to drop a resource in, and then Steward picks it up and translates it into the right thing on the backing Cloud Foundry Service Broker. So here's a super detailed flow. I'm not going to get too much into this, but we will share these slides. This is kind of the workflow from an application developer perspective on how, after discovering a service they want to use, how they go about talking to Steward to get access to the service, get the right credentials, and so on and so forth. And then this one I'm actually going to omit almost entirely. This is the full architecture diagram on how Steward works. We're actually going to be dropping this diagram into the Steward repo in the next few days to kind of show at this level of detail how Steward is doing the translation between the Kubernetes resources and the backing service broker. So you can see there's 5 major operations that it translates into. And then eventually the application gets access to that backing service provider via a Kubernetes secret. So finally, up next, we've got an Alpha 1 out right now that implements all of this functionality I mentioned. And coming up in Alpha 2, as I mentioned at the very beginning, we're starting to coordinate a lot more closely using our prototype with the special interest group. And then also we put a lot of work early into integration testing to make sure that as we kind of evolve the Steward product, it stays true and actually functions as we intend, using that communication via Kubernetes resources. And then coming up after that in Alpha 3, we're actually starting to pursue a lot deeper hooks into Kubernetes. So that third-party resource hook is kind of the beginning of what you'll see as baking this thing in a lot deeper into the Kubernetes core or something very similar to the core. So that's it for me. I actually wanted to open it up for questions if we've got any. And then otherwise, I think I'm going to be kicking it over to Gabe or, yeah. Yeah, so I'm going to stop sharing and open it up for questions if anyone has any. Give it 20 seconds or so if anyone thinks of anything. Otherwise, I'll assume I did a perfect job and this is the best product in the world. Yeah? Okay. So we'll kick it back to Gabe.
Thanks, Aaron. It's interesting. Steward is, on the one hand, a pretty abstract problem domain that it's tackling, so it can be kind of difficult to wrap your head around it. But once people start to bump into this problem of basically node passing and what really amounts to a shadow dependency graph between a bunch of your services, and not something explicit and managed via any kind of policy, but just by virtue of node passing, you start to really feel the pain. And I think that there's folks who've experienced that are actually quite excited about Steward, is at least what we found in the wild. So we're quite happy with the reception to date, and look forward to aligning our efforts with those in the SIG-Service-catalog that you mentioned. So since we don't have any other questions, I guess we can wrap it up for today, and we will see you again next month, same time, same place. Thanks, everyone.